Today we're going to talk about interpolate and extrapolate. Go ahead and get the title and today's date, as well as separating your page from left side and right side. So we're going to start with an example, and then I'll explain what interpolate and extrapolate actually are. Several members at a gym were asked how many minutes they worked out at a gym that day, as well as how many calories they burned. Their answers are represented on the scatter plot below. Write an equation for the trend line. So they give you the trend line, so you have to write that equation. The first thing we need to figure out is the slope. So the slope is m equals, well, I see this coordinate here, which is 2300. And then I see that it goes through the origin. So I can say 300 minus 0 over 220 minus 0, which gives me 300 over 20, which simplifies down to be 15. So my equation is y equals 15x. What does the x represent? The x represents, in this case, the time spent working out in minutes. What does the y represent? The y represents calories burned. So we can see what this information is. We have the equation for the trend line or the line of best fit. So let's go ahead and answer these questions. So when answering questions about a situation, you are either going to interpolate or extrapolate. Now, interpolate means to find new data by estimating within the data set. Interpolate means that you're finding an approximation for a value based off of your trend line within the data set. Extrapolate means to predict a value outside of the data set by using an approximation from within the data set. What you do to extrapolate is you use the line of best fit or the trend line to predict what could happen outside of the data set. Now, mathematically, extrapolate is something that we don't believe to be true because we are predicting something that we don't have data to support in that specific area. But we can say this could happen based on previous data. This is what could happen. So, how many calories would you expect someone to burn if they spent 120 minutes at the gym? So going up to the graph doesn't even go up to 120 minutes. So I wouldn't be able to use the data set to figure out what this value is. So we are extrapolating here, but I can use the trend line because I have an equation that represents this within the data set. Now I would say 120 minutes, which we stated above, x is the number of minutes. So I would say y equals 15 times 120, which equals 1,800 calories. So if they worked out for 120 minutes, we would expect 1,800 calories to be burned. If someone burns 1,740 calories, how many minutes would you predict they've spent at the gym? So again, using the trend line, I would say 1,740 is equal to 15 times x, divide by 15, x equals 116 minutes. Now, before we go on to questions 3 and 4, I want to talk about these. There's some extenuating circumstances in predicting these values, and what you want to think about is the situation. Is it possible for someone to work out for 120 minutes? Yes, it is definitely possible for someone to work out for 2 hours. What happens though is your body reaches a point where it doesn't burn as fast as it had originally, so the process of expelling energy slows down, your body gets tired. It could also speed up. You could work out for that amount of time, but your workout could change, the intensity could change, which would lower the amount of effort going in, which would lower the amount of calories burned for that particular activity. And the same thing for question number 2. You could work out for 116 minutes if you consistently did the same exercise for those 116 minutes, which is a feat in of itself. You could be continuously burning that same amount of calories. This is one of the reasons why extrapolating is not seen as a mathematically sound way to use data, because there are a lot of things that could change. And also, sometimes this is just unrealistic. I think 2 hours or 116 minutes, I think either of these are realistic. I think burning 1,800 calories is realistic. There, again, are extenuating circumstances. I think burning 1,740 calories is also realistic. But sometimes you get information that is not realistic. Like, if we were to say, what happens if you work out for 4 hours straight? That is not really something that anyone could do. Your body reaches a limit. There's always a realistic element to looking at this information, and you want to keep that in mind. So let's move on to questions 3 and 4, and then you guys can work on some practice. So what is the slope of the trend line and what does it represent? The slope of the trend line is 15 calories per minute. That's what it is. That's what it represents. What is the y-intercept of the trend line and what does that represent? The y-intercept is 0, 0. Remember, when it asks you about a specific coordinate, you write it as an ordered pair. It's 0, 0, and it says, what does it represent? That means we interpret it, and it says you spend no time exercising and burn 0 calories. Scientifically, we know that this is not true because just the process of being awake and alive, you burn calories. Your body works through energy. That's why you get hungry, even if you're doing nothing, because you need to fuel your body. But anyways. Okay, so that's it. That's the end of these notes. Please go ahead and work on the practice questions. Let me know if you have any questions, and then come back and write a reflection.